diagram I'm bringing. So they are in contact. So the line of impact will be common normal for the line of impact. This is at the ground. Now directly get into the problem. This is C1. This is C2. How the velocity V0 will be acting like this. So here this velocity V0 you should resolve along line of impact perpendicular to line of impact. Only component of velocity is along line of impact will be taking at that one. And this is at rest here. So how the impulse will act here in this direction. What about the impulse here on the hemisphere in this direction, on this sphere in this direction? After collision, what do we expect the velocity of colliding objects? So let this be the V1 parallel. The velocity of this would be V2 parallel. Component of velocity V1 perpendicular like this. This is a 2m, this m. So we need this theta. So the theta can be obtained from the triangle C1, C2, this is R, this is 2R. Find the speed of hemisphere and solid sphere after collision is asking. So this much is there. So in what action I can apply conservation of linear momentum? Any direction? This is very important. Let's see that how you analyze. In what direction I can apply conservation of linear momentum? Any direction or only one specific direction? This component of impulse will act on the ground, and because of this, impulse by the ground will come into picture. So therefore, quotient of applying conservation of linear momentum along line of impact. What is the problem? Component of impulse by the ground will come into picture. So therefore, the momentum should be conserved only along x-axis. Because of that, what means j cos theta, j cos theta. Net impulse will be 0. So momentum is not conserved along y-axis and also along line of impact. Are you getting that? Why this impulse by the ground will come? Component of impulse j sin theta. Here you see this is theta. J sin theta will act downward. And what happened? The hemisphere will suddenly press the ground. The ground will also will exert equal and opposite force suddenly. And that is what the impulse. The impulse by the ground will come into picture like this. So this component of impulse will act along line of impact, unbalanced. See, these two will be balanced, plus j minus j. What about this is unbalanced? So therefore, momentum is not considered along line of impact. So applying conservation of linear momentum along line of impact, along x-axis only. Slowly you have to be careful. So what is initial momentum? 2m v0. Finally, 2m. I should take this. This is theta. This is theta. This is theta. After this should be so v1 parallel cos theta. Then another component. To m v1 perpendicular sin theta plus m v2 parallel cos theta. Okay, fine. So this is the one equation what we have. What is v1 perpendicular? V1 perpendicular should be equal to v0 sin theta, because I'll resolve this velocity. V0 and V0 sin theta is what? V1 perpendicular. So we have already information. What is V1 perpendicular? V1 perpendicular should be equal to V naught sine theta. Okay, we got this one. So let's write one more. Unknown things are then V1 parallel, V2 parallel. V1 perpendicular, I obtained it. I'll go for quotient of restitution. There should be V2 parallel minus of anything directed towards right, let it be positive, by V naught cos theta. Initially this is a test, no? So solving this, E V naught cos theta equal to V2 parallel minus V1 parallel. Solving these two will get the required answer. So now find the speed of hemisphere and the solid sphere after collision is asking. So there's one simplest way of doing this problem. Check it, make observation.
Sir,
Uh,
sir, E in denominator, for the equation of E, sir, we should take V naught, no, sir. Line of impact is along x-axis.
line of impact, how is the red color line are you not seeing? Line of impact should be along common normal, no? Am I right? The line of impact should be along common normal. Or you could have done that one after collision, the velocity of sphere, let it be. And now one more thing, you look at this. Can this, let's be practical. Huh? That's what general we think it. How the hemisphere will move after collision? Will move into the ground. After collision, how the hemisphere will move along x-axis. How the sphere will move along x-axis. I think something somewhere we got into collision and we are messing up things. So shall I show V2 parallel like this or V2 along x-axis? V2 along x-axis. This what again, line of impact resolving all here to be not, don't bother first that one. Practically what will happen after collision? The hemisphere will move horizontally and the sphere will move horizontally. So how the velocities of sphere and hemisphere should be after collision? Should be horizontal. But we did something like this, no? Check it, no. This will not match the answers. You have to look at the calculation. So what should have been the best way of doing this problem? First, naturally, how do they move? I just shown because students will get carried by the collision ideas. But finally, how do they can move? Because the ground will play important role here. So we have forgotten totally the effect of ground. The ground will see that they'll move horizontally. The ground will see that they'll move horizontally. So what actually basically happens here is, no, this is the line of impact. Now, what is the possible direction in which the sphere will move? It will have velocity v1. This will have velocity v2. It's very simple, this much only. And there's a line of impact. Now, this is theta. This will be theta. This will be theta. So this is the velocity v2. This is m to m. Why, like already shows the component of impulse by the ground will act along line of inch, so momentum is not conserved. So therefore only along x-axis it's conserved. So I'll write it very simple equation. 2mv1 plus mv2. So 2v0 equal to v1 plus v2. See, nothing wrong. In the first way, what happened? We just carried on by that impulse, all that particular thing. There's a ground. The ground will put some restrictions on the motion of this one. Then along line of impact will apply quotient of restitution. E equal to V naught. Finally, how much it is? V2 cos theta minus V1 cos theta. Both are directed in the action divided by V naught cos theta. So E equal to E V naught. Solve equation 192. You'll get the required answer. No, there's a difference in answers. You'll get it. Sir, what's wrong in thinking like this? Because the very basic assumption is itself is wrong. No, you are just assuming that the hemisphere will move. No, the ground will not permit the hemisphere to move like this. So here is what we went wrong. Getting this, I'll just retain because when two-dimensional collision comes, no, you have to be very careful. So wrong assumption. So the second method is what you should think. This is correct. Just by impulse, you should not bother. You should look at the other constraints that are put by the ground. Okay, so I deliberately, I wanted you to analyze here. You can't take things for granted here. So you're not just colliding objects, even the ground will play a role in deciding the motion of the colliding objects.